Okay, well, my name is Nicholas Lane. I'm a co-founder of Flower Labs, a professor at the University of Cambridge, and I want to officially welcome you to Flower AI Day.
Good. So we're here to explore one massive idea. And what's interesting that this massive idea, it starts, but it doesn't end with superintelligence. We're luckily enough at Flower, we work with over 2,500 organizations, enable them to build various kinds of AI. So we are rapidly seeing the emergence of superintelligence in various forms, in various contexts, in various industries. But what's fascinating is that we're also starting to see the arrival of a very special and an important form of superintelligence. We don't believe it's being talked about enough currently. The first attribute of the special form of superintelligence is that it's decentralized. And so what that means is when you do training, when you do inference, it doesn't matter where the data is, it doesn't matter where the compute is, you can still train in a decentralized fashion. The third part of this special recipe is open source. When you combine the three of these things together, so you start with superintelligence, you enable decentralized, and you maintain open source, you have a recipe that we believe to be, something that's truly special. It's open, it's transparent, it's collaborative, it's efficient. Essentially, you can safely use all of the world's data, you can safely tackle all the world's problems, and today we are going to investigate this reality. For us to investigate this special topic, this special form of superintelligence, we have assembled an all-star lineup of AI folks from various kinds of organizations. We have folks from Red Hat, Meta, Cohere, Coinbase, JP Morgan, Amazon. You name it, they're here, folks, to tell you about this special form of superintelligence that's emerging. You're going to see, over the course of the next few hours, 9 talks, 3 networking sessions, 2 fireside chats, and 1 massive panel at the end where we're going to wrap it all up and see what we do next. Be sure to stick around, because in the evening we're going to have a dinner and an open reception full of cocktails to discuss what we've just digested. But with that, let's start with our first technical talk. I'd like to introduce Daniel Beutel to the stage. He's a co-founder of Flower Labs and co-creator of Flower. Over to Daniel.
Really happy to be here. This is a special place. As some of you might know, a lot of Flower's history has started or has happened very close to here. Let's take maybe a big step back and see where it all started. So not everyone knows this, but the birthplace of Flower is actually at the University of Cambridge, specifically the Machine Learning Systems Lab. We researched ideas that we thought were underexplored, ideas where we thought those ideas are important enough so that they can help us to unlock new kinds of AI systems. And Federated AI was one of these. We believe there was more to the story, more than people commonly talked about at the time when you heard things about Federated AI. When we started to work on this, we realized there wasn't really a toolkit or a framework that allowed us to do what we wanted to do, the way we wanted to do it. So we built this. This is Flower's logo. And many here will probably have used the framework before. So this is probably old news, but the Flower framework is now the world's most popular federated AI framework. It allows you to federate practically any kind of workload, run it in a decentralized way, run it on data that's not under your control, and do so in a privacy-respecting, secure way. Now, since we started this, Flower has gotten a wonderful global community, and AI developers really, many seem to love the framework passionately. So we have more than 6,500 developers on the Slack channel. There's a lot of other projects on GitHub, for example, that build on the project. So whenever someone wants to get started, they can just go there and they can go through these vast resources and pick something and build upon that. Here are some impressions from our community. So this is really a wonderfully global community. For example, in March, there was the Flower AI Summit, which is now the largest federated AI conference in the world. The room was packed. Maybe it was a little bit too packed. So I saw some people sitting on the floor, so apologies. Tomorrow we'll run the Decentralized AI Hackathon at Stanford. We have over 600 registrations now. I think people are still signing up. We unfortunately only have 200 spots, but it shows that the topic is really, it's something that many people are really passionate about. We recently crossed an important milestone. We crossed 2.5 million downloads, 1 million for the stable version, 1.5 million for the nightly version. A lot of people like to use the latest and greatest that we just merge into main. And it's not just used in research. There's actually a huge community that uses Flower to deploy production systems. We have, what I find interesting is it's used across very different industries. We have companies in the consumer space, companies like Samsung and Mozilla. We have companies in the industry space like JP Morgan and the NHS. In academia, Stanford, Berkeley, MIT, Oxford, all of them use Flower in some way for some kind of research. And there's also other organizations like the hyperscalers and, for example, the US Air Force that use Flower for their projects. Now, because of this strong community adoption, in 2023, we decided to start Flower Labs as a company. We moved to San Francisco, we went through Y Combinator, and went all in on this idea. Not just do it as a side project in research while being researchers, but really double down on it and go all in. So maybe this begs the question, why? Some people still perceive federated AI as sort of this niche within AI. There's AI, and then there's decentralized approaches, and then there's federated AI as sort of this thing to do to preserve privacy or something else. But actually, our perspective was always a very different one. And for that reason, I want to zoom out a little bit and share my perspective and share our perspective on why we think this is so important for the future of AI. So why should you even care about federated AI and decentralized AI? There are so many different perspectives, so I just want to share ours. We strongly believe that federated AI is the missing piece to unlock a new era of AI. It's not just one area, but it's really a new era in many different areas. So what do I mean by that? So what's required to build better AI systems? The recipe for building better AI systems has been proven time and time again. The recipe for building better AI systems, in one word, it's just scale. You scale the model. If we compare it with the now historic AlexNet milestone in 2012, we scaled the model from 62 million parameters to now there's models with over 2 trillion parameters. If we look on the compute side, AlexNet was trained on 2 GPUs. There's now clusters with 350,000 GPUs, soon to be over 1 million GPUs. And on the data side, in 2012, we used ImageNet, and now modern training runs like Llama 3 or DeepSeek R1, they use all of the data that's publicly available on the web. Now, if we zoom into this a little bit and try to understand the data side of things better, we can see that both Llama 3 and DeepSeek R1, they were trained on roughly 15 trillion tokens. And 15 trillion tokens is pretty much the number of tokens that you can get that's publicly available, that's high quality English tokens on the public web. And this was a pretty big jump. If we compare that to GPT-4, GPT-4 was trained on just 5 trillion tokens. But not all data is public, right? So if we continue to think about this, there's a lot of non-public data, but how much is it really? Is it maybe another 15 trillion tokens? Is there more data that's not public? Is it maybe 10x? 10x would be pretty big. It would be a pretty big jump of untapped data that's out there, wouldn't it? I want to invite all of you to just take a guess. How much more data is out there that's not public? And maybe just remember your guess for a second. How much more is there? Okay, ready? This is it. So it doesn't quite fit on the screen. It's one of the best estimates that I found is that there are another 2,000 trillion tokens of non-public data. And this estimate is actually a conservative estimate. There are other estimates that put the factor to 1 million or more. So I think this is quite an important part, and let's zoom out to see the full picture here. On the left, you see those 15 trillion tokens. On the right, you see the 2,000 trillion tokens of non-public data. And what's probably obvious now is that this very small dot on the left, this is the data that was used for DeepSeek R1. This is the data that was used for Llama 3. And this huge dot on the right, this is the data that is barely used. There's a lot of data that you could possibly tap into. A lot of data owned by organizations, by enterprises, that is currently not really being used, and that could be used to build way better models in many different domains. So there's this factor of 133x. It's not just 10x the public data, but it's over 100 times the data that is currently not being used. It's a massive opportunity for organizations to build their own models that leverage this non-public data. And just remembering back and knowing how scaling up the data has improved model quality over the last couple of years, I can't wait to see what kinds of models it would unlock if we were able to leverage more data. So then the next question obviously is how. I think by now we understand the opportunity that is out there, but how could companies or organizations start to use that data? It's non-public, so it's often sensitive and it needs to be protected. Well, the traditional way to use more data has been what we could call centralized AI. The traditional way was, let's build a bigger and bigger GPU cluster, and then let's move all of this data into the GPU cluster. We can call that centralized because it's a centralized cluster and all the data needs to be moved into it. But this is also the challenge here. Not all data can be moved. A lot of data is out there that is owned by organizations, it's sensitive, and it cannot be easily moved into someone else's compute cluster. So there's also a different approach, which is called Federated AI. Sometimes also decentralized AI. They share many of the same ideas. In this approach, we just don't move the data. We leave the data where it is, where we leave it under the control of the organizations that own it, or under the control of the users that own it, and it remains under their control. The traditional approach was to move the data to the computation. The approach in Federated AI is to move the computation to where the data is. And the data just simply stays where it is. By doing that, we can access much more data and we can access it in a safe way, and it remains under the control of the data owners who need to protect it. Now, if you want to learn more, last year we released a course with Andrew Ng. It's two courses. So there's one course that is an intro to Federated AI, and there's a second course that covers federated fine-tuning of LLMs. Andrew is also the person who said, AI is the new electricity. And I think this quote is just spot on. AI is already having a substantial impact on society. Going forward, I think this impact will only get bigger. And I think if we if we start to think about AI in terms of electricity and compare it, I think there are some quite a few interesting learnings we can maybe get from the history of electricity. So let's see. The history of electricity in the US is quite interesting. I had to Google a lot of this to understand it myself. But in 1882, there was an important historical milestone with the Pearl Street Generating Station. That station was in New York. It was built by Thomas Edison, and it produced power for Wall Street. And the sole purpose was to produce power to keep lights on at night and to allow people working on Wall Street to work during the night. As we would say today, it was co-located. So it was in very close proximity to produce the power, and then the power was consumed basically right next door. Another important milestone, and this that challenged this notion of co-location, this requirement for co-location, was 7 years later. It was the first US transmission line. It was built in Portland, and it allowed transmitting electricity over 13 miles. It's not a lot, but at the time it was considered a major technological breakthrough. So for the first time, you didn't have to co-locate the generation of electricity with the consumption of electricity. Fast forward to this year, I think we all know how the history evolved. Today, we have a fully integrated electricity grid across the entire continent. And it's decentralized in nature. There are large power plants that produce electricity, and then consumers, they might be very far away. But sometimes there's also just some smaller players. Maybe someone could be as small as someone just having a solar panel on their balcony, and they would contribute some electricity back to the grid for someone else to consume. Now, if we look at AI today, it looks a little bit like electricity before the power grid. If you want to do AI, you have to do everything in one place. You have to have the GPUs, you have to move the data to where the GPUs are. And if we look at where the data actually is and where those GPUs actually are, they're globally distributed. We can see a lot of dots on this globe here. And what we notice is that there are a lot of data silos, there are a lot of siloed GPUs, and it's actually pretty hard for them to work together. So in a sense, it feels a little bit like we're in a pre-grid era of AI. But we're working hard to change that. Today, we're super excited to introduce Supergrid. Supergrid is the next evolution of the Flower framework. With the Flower framework, we've basically built something like the Git of Federated AI. Everyone uses it to build their projects. Industry uses it to build their projects and deploy production networks. Researchers use it to prototype and research new approaches. But from our experience, it's sometimes still too difficult to set up these new networks and adopt federated AI for some project. This is why we've built Supergrid. Supergrid allows you to easily connect data and compute and do so globally. Data is naturally distributed, compute is naturally distributed, and with Supergrid, you can soon build just ad hoc federations to work with data and compute that is located anywhere in the world. So Supergrid was a big engineering effort. We changed a lot of things under the hood to make this possible. We reworked the entire communication stack. It's now one of the best communication stacks to train LLMs in a fully distributed and decentralized way. And we made a lot of additional changes under the hood to power this new system. So Supergrid is compute, it's data, and it's connected. But the most important part is it's owned by you and it's controlled by you. If you connect your data or if you connect your compute, it remains under your control, but it suddenly becomes very easy to collaborate with others. Supergrid is the next evolution of the Flower framework. We're already working with a number of customers who use Supergrid, We'll open up early access to more interested parties in Q4 of this year. And if you're interested in working with us, there's a QR code on this slide that you can use to apply for early access. I'll leave this up for a second because I see a lot of phones in the air. But you can also find it on flower.ai/early. So this is SuperGrid. It's the next evolution of the Flower framework. And we can't wait to share more during Q4 with you. Let's shift gears a little bit now and talk about Flower Intelligence. So Flower Intelligence is a way to easily run LLMs on device. We introduced it earlier this year at Flower AI Summit in London. It's a simple SDK. If you've used any LLM SDK to do LLM inference, you know how it works. But the big difference is that as opposed to the traditional way of just taking your prompt and sending it to a remote server, in this case, the SDK actually fetches the model onto the device and then executes all subsequent requests on the model on the device. So it's fully offline capable, it's fully privacy preserving because it runs on device. It's supported in different SDKs and languages for typical mobile and web platforms. But sometimes you still want to use a larger model, a model that just can't run on the device. And for that case, you might want to run a server. You might want to put the model on a server. For that case, we built a confidential remote compute. It's the perfect companion to Flower Intelligence. So Flower Intelligence runs the model on the device whenever it can. But if you want to run a bigger model, or if the device is just not capable enough to run the model on the device, Flower Confidential Remote Compute can encrypt the prompts and the responses to protect your sensitive data and send them to a remote server to execute a bigger model there. So Confidential Remote Compute, we introduced it as a private beta in March. And now I'm happy to announce that Confidential Remote Compute is now available as a public beta. So this means you can just go to flower.ai, create an account, sign up, and try it out. So that's our update on Flower Intelligence. It's an on-device AI SDK with optional confidential remote compute. And what we see is that using this SDK unlocks new capabilities. It allows users to use AI in situations where they just couldn't use it before. On sensitive data at Flower AI Summit in March in London, we shared that Thunderbird uses it for very confidential information, your emails. And if users don't have to worry about data leakage, they can suddenly adopt LLMs for a lot more things. So to explore that direction further, we worked with one company to build and think about what kinds of new applications this could enable. And this organization is Mozilla. So we worked with our friends at Mozilla on a research experiment. And for this research experiment, we had one driving question. And that question was, what could a context-rich AI assistant look like? So how could we securely provide richer context to models while being transparent to the user, putting the user in control, but building better agents and building better AI assistant because those have more just richer context. And if we remember this slide, it's a big part of our motivation. Traditional advanced AI assistants like deep research achieve their results by tapping into web data. They use web search to fetch additional information apart from the prompt that the user passes to them and give a richer and hopefully better and more helpful reply to the user. But if you remember this public versus non-public data situation, then it's also painfully obvious that there's just a lot more data out there that is possibly very helpful to the user to give better and more helpful replies to the user. So web search is only a small part of a much bigger picture. A truly helpful assistant would be able to use a lot more context about the user and put the user in control over what kind of context they want to share with the assistant. So there's a ton of context that's often relevant to be helpful, but right now with most AI systems, this context is simply missing. MCP is trying to change this to some extent, but there's also a lot of challenges with adopting MCP at scale. So we thought about what should a better AI assistant look like? How could we make AI assistants better by just being more content rich? And content rich was obviously that was sort of the driving motivation. We also thought about what are other requirements that we would have for such a system. For example, the system should definitely be open source. We have a long history in open source, and open source is also one of the core pillars of the Mozilla Manifesto. It should be secure. It's a key requirement. If we have context-rich systems, security is more important than ever. We'd also like it to be modular. So as a user, if I think about my perfect system, I would like to choose which kind of model do I want to use. I would like to choose which kinds of data connectors do I want to use. I also want to choose to some extent how do I want the model and the AI assistant to behave. So do I just want a regular chat AI assistant? Do I maybe want to have a study companion? Do I want to have a sort of a sports coach that helps me with some things there? So ideally, an ideal system is modular and composable, so that these different things can be composed in a natural way. It should also be permissioned, of course, because if we expose more data to the system, then the user needs to be in control and needs to be able to control when and what kind of data is exposed to a single inference run. And last, but definitely not least, it should be extendable. It would be great if we can build a starting point, but from our vast experience in open source, we know that users often, and the developer community out there often have a lot better ideas than we do. And we want to empower them to build these plugins into such a system. And this is aligned with the Mozilla Manifesto. It's a human agency. It's transparency and decentralization. And of course, it's all built on open source. So we built an experiment, and this experiment is an experimental browser. This experimental browser uses a modified version of Chromium. It uses Flower Intelligence to showcase what a context-rich assistant in line with these values could look like. So let's see it in action. Please keep in mind that this is a very early prototype. It's not polished at all. It has a lot of rough edges, but we're excited about it, and we still wanted to share it and start a conversation around what this future could look like. All right, so it looks like a regular browser, and it has a couple of extras built in. So there's a regular interface. You can just ask any kind of question that you would usually ask. I'm not going to show this because we've all seen this before. Let's instead look at one of the tabs. I just open up a random tab, and I found this interesting looking gaming monitor here. So I wonder, is this relevant for me? The specs sound amazing. So if I just mark this text, then we can see this small helpful thing here where it helps me to, it suggests to me to explain this. And I could run this now to get an explanation, but I can also click into it and ask it something. So maybe, do I need 240 hertz and 4K for coding? And then when I run this, it uses, it triggers the AI assistant. We can see it coming up in a side panel. And then we see the reply of the assistant. It tells me, no, you don't need 240 hertz for Sometimes it makes mistakes, but anyways. All right, no excuse to buy this monitor, but I'm still, maybe I should still try it. So I can go into full screen mode and ask it a question. There's different modes down here. There's a search mode, there's a deep research mode. I can also switch to a different model. Let's use deep research. I want a really comprehensive report on these amazing gaming monitors. Let's kick that off. Once we kick it off, it starts to plan the deep research. We can see the different kinds of queries it would execute. We can see the different kinds of data sources it would use, data sources that are connected. And we can really follow what it would do. It's now asking me whether it can have access to the browser tabs, because it sees there are some browser tabs open, and I can decide to always allow this or maybe just allow it once. It also asks me whether it can use Google Mail and Calendar. For this purpose, I think it probably doesn't need access to my email. There's not a lot of relevant email in there. So once I took these decisions via the permissioning system, it goes off, it takes these searches, and it starts to compile a comprehensive report on these gaming monitors. So this will run for a while. It's a really comprehensive report. So while this is running, let me show you something else. Under the hood, the way this modular system is working and composed is it's based on 3 primitives. We can start with connected apps. Connected apps is basically the data that you give the system access to. We can see web search, we can see browser tabs. I've configured Google Mail and Telegram here. And then for each of these, I can take a decision on whether I just want the system to always be able to go ahead and just pull information from that, or whether I want the system to ask me whether it's allowed to access the system in a particular case. So for browser tabs, I think it's always fine. So I'm just going to change that to always allow. Next is AI models. We all know what an AI model is, I think. So there's different models that are supported. You can easily add additional models. And then the one thing that maybe stands out a little bit is AI modes. So AI modes is the way that this AI assistant would behave. We have 3 standard modes, which is just regular chatting to the LLM. We have a search mode that goes out and searches and then compiles a relatively short answer. And we have deep research, what we've just seen. There's also other modes, and you could add arbitrary modes here depending on how you want the agent to behave in the end. So let's just enable study mode, and then we can see that down here, it now offers me to use study mode. And I can use study mode with any kind of model that I want to use it with. Let's try one last thing. Let's go to flower.ai/early. And let's see if we can share this with everyone. Share this with all. Because the system has access to Google Mail and other things, the system can also take actions on my behalf. As we've seen in some other situations, this can be a little bit dangerous. So it's very important to have a strong permissioning system in place that prevents any accidental actions taken on your behalf. So in this case, it just shows me, it asks me, do I want to send this email to all Flower AI Day attendees? I can look into the full content. And here you can see this is a prototype. It's not polished yet. But in this case, I'm just going to allow it. And then the system will go ahead and will take certain actions. So now it says email sent successfully. So that's a very early preview of a very, very early prototype. We are still, as you can see, it still has a bunch of rough edges, but we are pretty excited about it, and we wanted to share it early. We wanted to start a conversation, and we wanted to hear what the community is thinking about this. Maybe we can switch back to slides. I I also want to say there's a lot of work left to be done. So this is also the reason why we don't open source it just yet. The purpose of showing this today is, again, it's to start a conversation. It's aligned with the values laid out in the Mozilla Manifesto. I hope you could see how the things in the demo relate to these individual items that we discussed earlier. And we want to get this right, so we'll start onboarding users in Q4. If you're interested in being one of the first ones to try it out, you can sign up for the early access waitlist. There's a QR code on this slide here. You can also go to flower.ai/early. And if the demo actually worked, then you should also have an email in your inbox sent by the system to you. So that's a wrap. We shared Flower Supergrid with you. We are very excited about this. It's available for early access. We shared an update on Flower Intelligence, and confidential remote compute is now available in public beta. And we also shared an experiment that we're working on. All of these 3 things together, they all relate to the opportunity we laid out in the beginning. This opportunity is this huge untapped data potential that is currently barely used, and that can be used to build better models and build better agentic systems if we find a way to safely and securely access this resource. That's it. I hope you have a great Flower AI Day, and I'm handing over to the next speaker.